Chapter 5, Section 4, solving special systems of linear equations. So, we're still solving the same way we've learned. Graphing, substitution, elimination. And we'll see why they're called special systems of linear equations here in just a second. We've already kind of talked about them a little bit. So, solutions of systems of linear equations. A system of linear equations can have one solution. It's where the lines intersect at one point. That one point is our solution, right? It can have no solution. That's where the lines are parallel. They will never intersect. So they don't have any solution because they're not intersecting. And they can have infinitely many solutions. That's where they are the exact same line. My lines are on top of each other, so they're intersecting at every single point. You guys kind of remember talking about that?
Yes.
So if the lines intersect just at one point, we have one solution. The lines don't intersect, they're parallel. No solution. The lines are the same, infinitely many solutions. Questions on that? Am I good to move on, or do I have people writing this down? Okay.
I'm writing it down.
I'll give you a little bit.
Better.
Am I good to move on?
Yes.
Or are we still going? Example 1. Solve the system of linear equations. So based on the thing that I have on this slide, what's one way I can solve this system of equations? By graphing. Very good. So by graphing, remember I just graph both equations on the same line, find their point of intersection. Correct?
Yes.
So the first equation, what's my y-intercept?
1.
It is 1. It's my b value, y equals mx plus b. So I put a point at 1 on my y-axis. What's my slope here for the first equation? 2 over 1. So which two directions am I going? And how many units?
Right 1.
Up 2, right 1.
Down 2.
From my y-intercept. And I'll get there in just a second.
Yeah. I'm ahead of the game.
Yeah, you are.
There's no solution. You read?
And what other two directions can I go?
Down 2, left 1.
Down 2, left 1. Connect my points. There's my graph of equation 1. Everyone good with that?
Yes.
Okay, let's graph equation 2. What's my y-intercept?
Using -5.
-5. So put a point at -5 on your y-axis. What's my slope?
2.
2 over 1. So what directions am I going again?
Up 2, right 1.
Up 2, right 1.
Oh no. We've called. I hope I don't. Go on.
Darn shame.
What other two directions can I go?
Down 2, left 1.
1.
That's my.
Connect my points. There's my line of equation 2. What do I notice about these two lines?
They're not.
They're parallel. They will never intersect. So if I'm looking for the point of intersection, they're never going to intersect. What's my answer? No solution.
Wonder how we got that.
You can write out no solution, or you can use the no solution symbol.
NS.
Everyone okay with that? Questions on that?
No.
Everyone okay looking at it graphically?
Yes.
Okay, let's solve this another method, using another method. What's another method I could use to solve this?
Elimination.
Elimination.
Actually,
So if you solve using elimination, I want x and y on the left-hand side. So for both equations, I'm going to subtract 2x to both sides. Right?
we do substitution.
Elimination.
Subtract 2x. Everyone okay with those equations that I got?
Yes.
Are my x's, y's, and constants all lined up?
Yes.
Yes, they are. In order to eliminate, we want same number, different sign in one of my x or y columns. Do I have that already?
No.
No? What could I do to one or both of my equations to get that?
Multiply the first one by -1.
Multiply the first one by -1. Oops. So -1 times -2x.
2x.
2x. -1 times y.
-y.
-y. -1 times 1.
-1.
-1. So now I'm looking at the second equation and my new equation after multiplying by -1. Do I have same number, opposite signs? Yep, so now I can add the two equations. So -2x plus 2x, what happens there?
Cancel out.
They're eliminated. What about y plus -y? What happens there?
Becomes 0.
They're eliminated.
Oh,
So
yeah.
if everything gets eliminated, what am I left with on that left-hand side? On the left-hand side, you said it earlier. 0. If all my variables cancel each other out, I just get 0 on that left-hand side, correct? What's -5 plus -1? -6. True or false statement? False. So once again, we knew the solution already was no solution. But this is what's going to happen if you solve by elimination. Both your variables will get canceled out. You'll be left with a false statement. That's when it's no solution. Everyone okay with that? Can I erase and do substitution? How can I do substitution here?
You sub, can I do this?
Yep.
You sub 2x plus 1 into the, well, I guess you can do it either way, but 2x plus 1 into the second equation.
Y equals 2x plus 1. So I can replace this y with 2x plus 1. Any questions on how I've substituted?
Not at all.
Okay, do I want to deal with my variables or my constants first?
Constant. I would like to do
Variables.
I'd like to.
Variables. Variables first.
Indeed.
And here's why. How do I get my variables on the same side here?
You subtraction that.
Subtract 2x. What happens when I do that?
They cancel out.
Cancels out on both sides, right?
It leaves.
This is why I want to do my variable first. I need to do my variable first. Don't do your constant first. Do your variable first. Because my variables cancel each other out. What am I left with?
1 equals -5, which is incorrect.
1 equals -5. True or false statement? False. So, once again, no solution. So, for substitution, if your variables cancel out on both sides, you're left with a false statement, no solution. Questions on all my methods with no solution? We're good with those. Can I move on? All right. Example 2. Solve the system of linear equations. -2x plus y equals 3. -4x plus 2y equals 6. Let's solve by graphing first since I have my graph up here. What do I need to do in order to solve by graphing?
Solve for y.
Get y by itself. What form do we call that? Slope-intercept form. So for my first equation, how do I get y by itself?
Add 2x.
Add 2x to both sides. So I get y equals 2x plus 3. And that's slope-intercept form, correct?
Yes, sir.
All right. Equation 2. What's my first step to get y by itself?
Add 4x.
Add 4x to both sides. 2y equals 4x plus 6. What's my next step?
Divide 2 to the whole.
Divide everything by 2. So 4x divided by 2,
2x.
2x. 6 divided by 2.
3.
Oh no, what do we see here?
Oh, they look the same.
It's the same exact line, right? Let's graph it real quick. Y-intercept,
3.
3. My slope yet again is what? 2 over 1. 1, 2, 1. 1, 2, 1. Up 2, right 1. Down 2, left 1. So here's my first equation. And then if I graph my second equation, it's just going to be right on top of it, correct? So what do we say if they're the same exact line? Infinitely many solutions.
And we're not allowed to put like INS.
Nope.
Or infinite solutions?
Nope. Infinitely many solutions. Any questions on that? Everyone good understanding it graphically?
Yes.
Because my lines are intersecting at every single point. And those lines are going to go on forever and ever. They're intersecting at every point. It's an infinite number of ordered pairs, so infinitely many solutions. What method do we want to use next? Huh?
Actually, elimination.
Elimination.
Already like that.
We'll be okay. Are all my x, y's, and constants lined up?
Yeah.
Yes, they are. In order to get the same number, opposite signs, I need to do what to which equation?
Multiply -2 to the top.
Multiply the top equation by -2. -2 times -2x.
-4x.
Positive 4x. -2 times y. -2y. -2 times 3. -6. Do I have same number, opposite sign now? Since I have same number, opposite sign, I can now add the two equations. -4x plus 4x. What's going to happen? Eliminated. 2y plus -2y. What am I left with on that left side? 0. Okay, what about 6 plus -6? 0. So everything canceled out. 0 equals 0. Is that true or false? True. So I would know it is infinitely.
So, is it always like going to be infinitely many solutions if it's 0 equals 0?
Well, is that a true statement?
Yeah.
Well, then yeah. If everything
All true
cancels out.
statements are infinite.
Say what?
All true statements are infinite.
Yep. Any questions on that one? Everyone good understanding it using elimination?
Yep.
Can I erase and move to substitution? Okay, which equation, would be easiest to solve for one of my variables in order to substitute? First one for which variable? Y. We already solved it for y earlier. What did we get?
Y equals 2x plus 3.
Everyone okay with that? So I know y equals 2x plus 3. So in my second equation, I can replace that y with 2x plus 3. I just take that y out, replace it with 2x plus 3. Everyone okay with plugging in, substituting? What can I do now? Distribute 2 times 2x, 2 times 3 equals 6. What happens with my x's when I try to combine them? They cancel out, and I'm left with 6 equals 6. True or false statement? True. So what's my answer? Infinitely many solutions. Does everyone see what happens for all three methods whenever it's infinitely many solutions? When they're graphed, lines are on top of each other. Elimination, both variables eliminate each other. I come up with a true statement. Substitution, variables cancel each other out, left with a true statement. So true statement means infinitely many solutions if your variables cancel each other out. After your variables cancel each other out and you're left with a false statement, no solution. Questions on example 2? Can I move on?
Yes.
Here's my assignment.
That took so long.
Pages 249 through 250. Numbers 2 through 26 evens. This will be due Wednesday, May 12th. This coming Wednesday on Canvas. Are there any questions before I end my recording?